When a neutral wire becomes loose in an electrical circuit, it can cause a number of problems, including overvoltage and undervoltage conditions. This is because the neutral wire provides a path for current to return to the power source. Without a proper neutral connection, current can become unbalanced, causing voltage fluctuations. In the case of a circuit, a loose neutral can cause a complete loss of power on the circuit. This is because the current has no way to return to the power source, so the voltage drops to zero. When the neutral wire is reconnected, the voltage returns to normal and the devices on the circuit begin to operate again. However, even if the neutral wire is not completely loose, a loose connection can still cause voltage fluctuations. This is because a loose connection can increase the resistance of the neutral wire, which can cause the voltage to drop. Voltage fluctuations can damage electronic devices, so it is important to have a qualified electrician inspect and repair any loose neutral wires. Here is a more detailed explanation of what happens when a neutral wire becomes loose. Firstly, when a neutral wire becomes loose, the current that is flowing through the circuit can no longer return to the power source. This causes the voltage on the circuit to rise. Secondly, the overvoltage condition can damage electronic devices that are connected to the circuit. Thirdly, in some cases, a loose neutral wire can also cause a fire. If the neutral wire is completely loose, the circuit will not be able to function. This is because the current has no way to return to the power source. It is important to note that a loose neutral wire is a serious electrical hazard. If you suspect that a neutral wire is loose, you should have it inspected and repaired by a qualified electrician immediately. Let's consider the scenario more deeply. Imagine a simple electrical circuit powering a light bulb. The electricity flows from the power source through the hot wire to the light bulb, illuminating it, and then returns to the power source via the neutral wire, completing the circuit. The neutral wire acts as a return pathway, maintaining a stable voltage level. Now envision that neutral wire becoming loose, perhaps at a connection point within an electrical panel. This loosening introduces resistance into the circuit's return path. This added resistance impedes the free flow of current back to the source. With the neutral connection compromised, the circuit no longer has a reliable reference point to maintain a consistent voltage. The voltage begins to fluctuate erratically, potentially exceeding or falling below the intended operating range. This is where the overvoltage and undervoltage conditions arise. Electrical devices are designed to operate within a specific voltage range, typically plus or minus a certain percentage. When the voltage deviates significantly from this range due to a loose neutral, the consequences can be severe. Overvoltage can stress the components within electronic devices, potentially leading to overheating, insulation breakdown, and even permanent damage. Sensitive electronic equipment like computers, televisions, and appliances are particularly vulnerable. Undervoltage, on the other hand, can cause devices to malfunction or operate inefficiently. Motors may struggle to start, lights may dim, and electronic circuits may behave erratically. Furthermore, a loose neutral can create an imbalance in the current flowing through different parts of the circuit. In a properly functioning circuit, the current flowing through the hot wire should be equal to the current flowing through the neutral wire. However, when the neutral connection is compromised, this balance is disrupted. The current may find alternative paths to return to the source, potentially overloading other circuits or creating dangerous conditions. In some cases, the excessive current can generate heat, increasing the risk of fire. The severity of the voltage fluctuations and their impact on electrical devices depend on several factors, including the degree of looseness in the neutral connection, the load in the circuit, and the sensitivity of the equipment connected to it. Even a slightly loose neutral can cause noticeable voltage variations, while a completely disconnected neutral can result in a complete loss of power or dangerously high voltage levels. To mitigate the risks associated with loose neutrals, regular electrical inspections are crucial. Qualified electricians can identify and address potential problems before they escalate into serious hazards. During an inspection, the electrician will carefully examine electrical panels, outlets, switches, and other wiring connections, looking for signs of looseness, corrosion, or damage. They will also use specialized equipment to measure voltage levels and check for proper grounding. If a loose neutral is detected, the electrician will take immediate steps to correct the problem. This may involve tightening connections, replacing damaged wiring, or upgrading electrical components. By ensuring that all electrical connections are secure and properly grounded, the risk of overvoltage, undervoltage, and other electrical hazards can be significantly reduced. In addition to regular inspections, it is also important to be aware of the warning signs of a loose neutral. These signs may include flickering lights, appliances that malfunction or operate erratically, outlets that feel warm to the touch, or a burning smell coming from electrical panels or outlets. If you notice any of these signs, it is essential to contact a qualified electrician immediately. Do not attempt to diagnose or repair electrical problems yourself, as this can be extremely dangerous. Electricity is a powerful force, and it should only be handled by trained professionals. To further enhance electrical safety, consider installing surge protectors and voltage regulators. Surge protectors can help to protect electronic devices from sudden voltage spikes caused by lightning strikes or power surges. Voltage regulators can help to maintain a stable voltage level, even when the incoming voltage fluctuates. These devices can provide an extra layer of protection for sensitive electronic equipment. Furthermore, it is important to ensure that your electrical system is properly grounded. Grounding provides a safe path for electricity to flow in the event of a fault, helping to prevent electrical shocks and fires. A properly grounded electrical system should have a grounding electrode, typically a metal rod or plate, that is buried in the ground and connected to the electrical panel. The grounding electrode provides a low impedance path for fault current to flow back to the source, tripping the circuit breaker or fuse and interrupting the flow of electricity. In addition to the grounding electrode, it is also important to ensure that all electrical outlets and appliances are properly grounded. This can be achieved by using 3-prong outlets and plugs, which provide a dedicated grounding connection. When an electrical fault occurs, the fault current will flow through the grounding wire back to the source, tripping the circuit breaker or fuse and preventing electrical shock. It is also important to be aware of the dangers of overloading electrical circuits. Each circuit in your electrical system is designed to handle a specific amount of current. If you exceed this limit, the circuit breaker or fuse will trip, interrupting the flow of electricity. However, if the circuit breaker or fuse fails to trip, the overloaded circuit can overheat, potentially leading to a fire. To avoid overloading electrical circuits, avoid plugging too many devices into a single outlet or extension cord. Also, be aware of the power consumption of your appliances and devices. High-power appliances like refrigerators, air conditioners, and space heaters require dedicated circuits. By following these safety guidelines, you can help to protect yourself and your property from electrical hazards. Electricity is an essential part of modern life, but it is important to use it safely and responsibly. In summary, a loose neutral wire is a serious electrical hazard that can cause overvoltage, undervoltage, and other dangerous conditions. Regular electrical inspections, awareness of warning signs, and proper grounding are essential for mitigating the risks associated with loose neutrals. If you suspect that a neutral wire is loose, contact a qualified electrician immediately. In the context of the original scenario involving the job trailer, the loose neutral in the panel caused a chain reaction of electrical problems. The computer, monitor, printer, fax, copier, phones, fluorescents, and microwave, all connected to the same circuit, were subjected to fluctuating voltage levels due to the compromised neutral connection. The surge arrestor, designed to protect against sudden voltage spikes, did its job by absorbing the excess voltage, but in the process, it became overwhelmed and emitted a burning odor. The key takeaway is that a loose neutral can disrupt the delicate balance of an electrical circuit, leading to a cascade of problems that can damage electronic devices and pose a fire hazard. Therefore, it is crucial to address any suspected loose neutral connections promptly and professionally. Let's elaborate on the consequences of a loose neutral in various electrical systems. In a residential setting, a loose neutral can manifest in several ways. Lights may flicker intermittently, appliances may malfunction or stop working altogether, and electronic devices may experience premature failure. Furthermore, The voltage fluctuations caused by a loose neutral can damage sensitive electronic components, leading to costly repairs or replacements. In a commercial or industrial setting, the consequences of a loose neutral can be even more severe. Businesses may experience disruptions in operations, equipment downtime, and data loss. Industrial machinery may malfunction, leading to production delays and safety hazards. Furthermore, the increased risk of fire can pose a significant threat to property and lives. The complexity of modern electrical systems necessitates a thorough understanding of neutral connections and their importance. Electrical codes, such as the National Electrical Code, provide detailed guidelines for proper wiring and grounding practices. Adherence to these codes is essential for ensuring the safety and reliability of electrical systems. Regular training and certification programs are available for electricians to enhance their knowledge and skills in diagnosing and repairing electrical problems, including loose neutrals. These programs cover topics such as electrical theory, wiring methods, grounding techniques, and safety procedures. By investing in training and certification, electricians can stay up to date with the latest industry standards and best practices. In addition to professional electricians, homeowners and business owners can also take steps to prevent loose neutrals. Regular visual inspections of electrical panels, outlets, and switches can help to identify potential problems early on. Pay attention to any signs of looseness, corrosion, or damage. If you notice anything unusual, contact a qualified electrician for further investigation. When performing electrical work, always disconnect the power supply before touching any wires or components. Use appropriate tools and equipment, and follow safety procedures carefully. If you are not comfortable working with electricity, it is best to leave the job to a professional. Furthermore, it is important to educate yourself about the risks associated with electricity and the steps you can take to protect yourself and your property. Read informative articles, watch educational videos, and attend safety workshops to enhance your knowledge. By being proactive and informed, you can help to prevent electrical accidents and ensure the safety of your home or business. Let's delve deeper into the technical aspects of a loose neutral and its impact on voltage distribution. In a properly functioning electrical system, the neutral wire serves as a common return path for current from multiple branch circuits. The neutral wire is typically connected to the grounding electrode at the service entrance, providing a low impedance path for fault current to flow back to the source. When a neutral connection becomes loose, the resistance of the neutral path increases, disrupting the voltage balance among the branch circuits. The voltage on some circuits may rise above the nominal value, while the voltage on other circuits may fall below the nominal value. This voltage imbalance can damage electronic devices and create other electrical problems. The extent of the voltage imbalance depends on several factors, including the degree of looseness in the neutral connection, the load on each branch circuit, and the impedance of the wiring. In some cases, the voltage imbalance may be relatively small and may not cause noticeable problems. However, in other cases, the voltage imbalance may be significant and can lead to serious consequences. To diagnose a loose neutral, electricians use specialized equipment to measure voltage levels and check for proper grounding. A multimeter can be used to measure the voltage between the hot wire and the neutral wire, as well as the voltage between the neutral wire and the ground wire. A ground impedance tester can be used to measure the resistance of the grounding path. If the voltage readings are abnormal or the ground impedance is high, it may indicate a loose neutral. In addition to voltage and impedance measurements, electricians also perform visual inspections of wiring connections to look for signs of looseness, corrosion, or damage. Loose connections are often characterized by discoloration, burning marks, or melted insulation. Corrosion can also weaken connections and increase resistance. Damaged wiring may have cracks, cuts, or exposed conductors. Once a loose neutral is identified, the electrician will take steps to correct the problem. This may involve tightening connections, replacing damaged wiring, or upgrading electrical components. In some cases, it may be necessary to replace the entire electrical panel. After the repairs are completed, The electrician will perform follow-up tests to ensure that the voltage levels are normal and the grounding system is functioning properly. The importance of proper neutral connections cannot be overstated. A properly functioning neutral connection is essential for maintaining a stable voltage, preventing electrical shocks, and protecting electronic devices. Regular electrical inspections and prompt repairs are crucial for ensuring the safety and reliability of electrical systems. In the context of the National Electrical Code, Section 250.24 addresses grounding requirements for separately derived systems such as generators and transformers. This section specifies the methods for connecting the neutral conductor to the grounding electrode, ensuring a low impedance path for fault current. Section 300.13 requires that the neutral conductor be continuous and unbroken, except for splices or terminations. This requirement helps to prevent loose neutral connections and maintain a stable voltage. Section 408.21 specifies the requirements for neutral busbars in panel boards. These busbars must be securely mounted and properly sized to handle the expected neutral current. Failure to comply with these code requirements can increase the risk of loose neutrals and other electrical hazards. In addition to the NEC, other standards and guidelines provide recommendations for electrical safety. The National Fire Protection Association, or NFPA, publishes numerous standards related to electrical safety, including NFPA 70E, which addresses electrical safety in the workplace. These standards provide valuable information for electricians and other professionals who work with electricity. By following these standards and guidelines, you can help to create a safer electrical environment. Furthermore, ongoing research and development efforts are focused on improving electrical safety technologies and practices. New materials, designs, and techniques are constantly being developed to enhance the reliability and safety of electrical systems. Staying informed about these advancements is essential for maintaining a high level of electrical safety. In conclusion, a loose neutral wire is a serious electrical hazard that can cause a wide range of problems. Regular electrical inspections, adherence to electrical codes, and ongoing education are crucial for preventing loose neutrals and ensuring the safety of electrical systems.